Now we're going to start applying the DeMorgan laws to identify what happens with the exclusive OR gate.
Okay.
The exclusive OR is made of 4 NAND gates. So I'm going to draw a diagram. The diagram looks like that. This is an AND gate. This is another one. This is another one. And here, right here, is another one. And now we're going to do the wiring to link all these gates together. They are going to be related exactly like that. Finally, this one. So this is what's inside a exclusive OR gate. Is the new function we're going to discover right now. If we put right here, just give me a second to change the color. If we're going to put right here the names of the inputs A, respectively B, how this is going to unfold to the end of it. Take a look. A is coming right here at the input of this first gate. Let's say the gate 1, 2, 3, and 4. But A is also coming over here because it takes the wiring. So the A is coming here, and B, same thing, it's coming on the first gate, but it's also coming on the second gate over here. So let's see. What is the output of the first gate? Is A times B, A times B, everything with the bar in the top. But now remember, this is the formula or the mathematical equation of the NAND gate. This is going to become the input of the next gate. So whatever is at each input, they are going to be multiplied like this, A times AB with the bar, and everything is going to receive a bar in the top. Why? Because of this little bubble over here. So this little bubble over here is going to give a big bar in the top of everything. Similarly, in the bottom is going to be B, this particular input, and times the other input, which is still AB with a bar, and all this is going to receive a big bar in the top of it because of this bubble over here. And what happens is these two are becoming inputs for the next gate, and the output, which is going to be our function, we put here the letter F from function, the function is going to be whatever is here, and we write it again, A times A, B, bar, and everything with the bar in the top is times the second expression, B times AB with the bar, and everything with the bar in the top. And because of this little bubble over here, this one is going to put a big bar in the top of the whole thing. Hey, take a look how complicated this expression became. And it's only made of 4 gates. Imagine that. So the purpose of all that is what? Is to simplify, to make that one looking simpler. It's too complicated. So for that, I'm going to write here in blue. Just give me a second to do it. Like that. I'm going to mark here in blue one of the DeMorgan laws. DeMorgan. And the law I'm going to use right now is this. A times B with the bar in the top is equivalent to A bar plus B bar. This is one of the two laws you've seen in the previous video. And now we're going to find out finally what can we do with that. So take a look over here. The purpose of using this one is to break the big bar in the top of the whole expression. This is what's causing the biggest trouble. But when you do this, as you can see, each of the two elements, they take half of the original bar. The mathematical operation right here, which was the multiplication, is converted into addition. So this is the consequence of splitting the bar in the top in two. So now let's apply this thing to the whole expression over here. So I'm going to put it here. The function is going to be equivalent to, breaking the bar over here in the top and changing the mathematical sign here from the multiplication to addition, like that. Is A times AB with the bar and with the bar in the top, and with half of the bar in the top of the whole thing right here, and plus, because the multiplication is switched to addition, B times AB with the bar in the top and with the bar, and with half of the whole thing in the top, and this is the new expression. But now, let's recall some of the Boolean rules. Boolean rules. And I'm going to write them here. Remember from the inverter, A with a double bar is the same as A. Because it's like you reverse this 180 degrees and 180 degrees again. So it's A. So whatever expression we have right here with two bars in the top, they cancel each other out. So these ones, they disappear. These ones, they disappear. So the new expression of the function is going to be A times AB with a bar, and all that plus B times AB with a bar. It's already looking simpler than the original one. But still, we have to apply it right here. We have to apply again the same mathematical rule. So we continue. The function equals A times A bar plus B bar. That's exactly the expression we have here in the top, the basic DeMorgan law. Okay? And all that is plus the other one, B times A bar plus B bar. So now what we have to do next is to distribute A to both terms here in the bracket, like that. The function becomes A times A bar plus A times B bar plus, now we do the same with the B. B has to be distributed for both terms here into the bracket. Okay? B times A bar plus B times B bar. But now we're going to face something very interesting, another Boolean rule I'm going to write over here. What is A times A bar? If A is 0, A bar is going to be 1. 0 times 1 is 0. If A is 1, A bar is going to be 0. So 1 times 0 is 0 again. So anytime you have something like that, any letter times its opposite, the result is always a big 0. So A times A bar here, they disappear. And the last one here, B times B bar, they disappear. And then we can have the final expression, which is function equals a b bar plus a bar b. I'm writing them from here in the alphabetical order. And this, if you allow me to change the color one more time, I'm gonna circle this one here. This is the expression regulating all the diagram over here, and this is called the exclusive OR. So if you pick up the letter X from here and the OR from here, this is why you can get XOR. So what is XOR? It's called exclusive OR. These were two Boolean rules we used for that. And then you have the mathematical equation of the exclusive OR gate. Don't worry, because we're going to use the exclusive OR. We're going to analyze it soon in the next video. Thank you very much. See you for the next one.